Hi, mathematicians. Welcome back to Math Workshop. Today, we're going to be working on recognizing and representing the groups of 10 in three-digit numbers and determine the number of hundreds in the sum of three-digit numbers. We're really going to focus on how we can identify those tens inside of three-digit numbers. So we're looking for you to think about place value and understanding rounding those whole numbers to the nearest 10 or 100. All right, put those math caps on, mathematicians. So here's our word wall. We remember that we were working with hundreds, tens, ones last time, breaking down those hundreds into tens. And then we have some ones. Today we're going to think about estimating and rounding. And you're going to need to remember the key fact that 10 ones equals 110, 10 tens equals 100. And we know that 10 hundreds equals 1,000. These charts are for you to refer to, use all the time. It'll help you think of numbers as tens. All right, so remember our math story. You had it on the Savas, and we also did it in class on the worksheet. But Mr. Jackson's class were collecting pennies. They decided to display them in stacks of 10. How many stacks can they make with 345 pennies? How many single pennies will they have left? Remember how we broke down our hundreds into those tens? And then we came up with 34 stacks of 10 and 5 pennies left over? We think of those stacks of tens in a group. We just box it, and that's basically the same as 100. So 10 tens made 100, another 10 tens made the second 100, and another 10 tens made the third 100. So we know that 3 groups of 10 tens, 10 tens plus 10 tens plus 10 tens equals 30 tens. Then we had the 4 tens that we can make 34 tens. But we want to think of those groups of tens as 10 tens plus 10 tens plus 10 tens. We know in our mind that's the same as the hundreds, but if we're valuing them at tens, that's how we would count them. So now, we thought about our groups of 10 inside of those 345 pennies. What part of 345 pennies is left? How many groups of 10 are there in 45? How many tens are there in all? How many ones are left over? So you can talk quickly what your thinking is around that. And this picture is similar to the one from the previous slide. We're just showing the whole number here. So 345, we know that there were 10 tens, which is that group of 10 tens, another group of 10 tens, another group of 10 tens, and then 4 tens. So we know that we're going to have 34 tens. And then we just have some 5 ones left. So that answers our question. How many tens are there in all? 34 tens. We knew that when we drew out 10 tens to represent that first 100 in the number 345. There are 300s, so we're going to need 3 groups of 10 tens. Okay. Now, let's think about this math story. You also saw this previously, but now we're thinking of how we're really counting those tens and valuing it as place value. The students in Miss Kennedy's class are collecting stamps from old letters. They are displaying the stamps in rows of 10. How many rows can they make with 428 stamps? Okay. Remember our math vocabulary, right? There are 10 tens inside of 100. So we have 4 hundreds here and 2 tens. So those 400s, I know that inside of one of those hundreds, there's 10 tens. Inside of the second 100, there are another group of 10 tens. And the third 100, there's another group of 10 tens. And the fourth 100, there's another group of 10 tens. So now 10 plus 10 plus 10 plus 10 is going to give me 40 tens. And then I have the original 2 tens that were in the number originally, which are left. So now 4 tens plus those 2 tens gives me 42 tens. And I'll still have those 8 ones there. So that would be our answer. How many groups of tens? 4 groups of tens and 2 tens. Altogether, we have 42 tens. So let's think about this. When we saw that there were 4 hundreds in and 2 tens in the number 428, it was the same as 42 tens. You can think of many numbers as tens. If looking at the equation 139 plus 265, we can estimate by rounding to the nearest hundred. We can use that thinking of these numbers as tens. I can see that there are 13 tens inside of 139. I can see that there are 26 tens inside of 265. So therefore, 13 tens and 26 tens is going to give me 39 tens. Okay, so now 39 tens, we know that if I'm drawing 39 groups of 10, right, that's going to give me 390. So the best estimate, right, because 390 is really close to that landmark number, 400, that best estimate would be 400. I would round up because it's only 110 away. Think about that 1,000 chart when solving rounding and estimating. Think about the nearest landmark number and make sure you're working in the place value you should in order to round or estimate. So your next steps, you have a Savas assignment, and make sure to discuss your strategies for how you are showing your groups of tens with a partner or a family member. All right, mathematicians, until next time, bye.